As you can see, there is a food chain existing in the soil. So we can see within the soil there is a macro ecosystem. Now let's talk about the soil profile. This is probably the last hard concept in this chapter I'm going to lecture about. The soil profile is a series of horizontal layers. So profile equals to layers. These layers have different chemical composition, physical properties, particle size, amount of organic matter. So there's a very general idea about those layers, and that's all I want you to know. And we can go into details whatever, but if you understand this sentence, you understand what is a soil profile. Of course, I'm going to give you details in a minute. Each recognizable layer of the profile is known as horizon. It's not vertical, it's horizon. Let's check out this very complicated slide. So this is how those layers look like. So the A horizon is the topsoil. It has maximum biological activity. And the E horizon, removal of materials dissolved or suspended in water occurs, which means in this layer, there's a lot of leaching going on. And the B horizon, that's called subsoil, and it's a horizon of accumulation of suspended materials from above. And when we talk about clay, most of the clay is in the B horizon. And as we can see, if the soil has an E layer, this is a typical structure of soil. That doesn't mean all the soil has those structures. This is a typical one, has everything in it. The E horizon, we can see there's a lot of root activities. And if we go in further down, the C horizon is a weather parent material. So those are the small pieces of rocks mixing with some of the soil. And R horizon, that means bedrock. And there's one thing I want to mention about is this O layer. It's a layer of organic matter. It's loose leaves, organic debris, partially decomposed. So this is where the nutrients come from. Some of the soil has O layers, some do not. The O horizon is made of litter, uncomposed or partially decomposed organic material. I'm repeating here because those are important for your understanding. A horizon is the topsoil or the uppermost layer. It contains most of the soil nutrients and living organisms. And in my regular face-to-face class, I will take students to nature trail to the campus so we can dig out those soil and see the A horizon. Most of the soil have A horizon, not all of them. And you just have to remember A horizon is the top layer of the soil. It's called the topsoil. E horizon is very nutrient poor. It's formed from leaching darker materials. So imagine the surface of the soil. The nutrients, the decomposition always happen on the surface, and when there's rainfall, those nutrients kind of leaching underneath. And that is one of the reasons why we see different layers. And the B horizon is the subsoil, as I mentioned, and the C horizon is a weather parent material, and the R zone, the R layer, R horizon is bedrock. I think in North America, there's like about 15,000 kind of soil identified. They could be grouped into three big groups, but these three big groups not including all type of soil, depending on where the soil is, how it's developed. So here it only shows you the forest soil, which is in the middle, and the grass soil on the left, and the desert soil on the right. And of course, if you look at the desert soil, the A horizon is very thin and poor. And if you look at the grassland soil, the A horizon is rich. It means this soil is very fertile. If you look at the forest soil, the A layer is very thin also. It has a lot of biological activities, but it is not very rich. And a lot of people think we can cut off the trees and cut down the forest and turn the forest land into crop field, which that is not a scientifically reasonable solution to growing crops. And you can see how poor that forest soil is. Why is that? I want you to pause a moment to think about the reasons why the forest soil supports so many plants and it is not really very fertile. It's because two factors. One is a high temperature. Most of the forests are in a warm area. Most of the year the temperature is high or warm and has a lot of rainfall. So when it's warm, the organic matter decayed very fast. And because of the heavy rainfall, those nutrients were washed away very quickly. And so most of the forest soil is enriched in iron and aluminum. And it's acidic. And it's not supporting the crops very well. So I want you to understand why the forest soil does not support the crop growth very well. So soil profile are the two features of the tropical forests. The high temperature leads to rapid decomposition. The heavy rainfall leads to leaching of nutrients. If we check out this picture, the mountain and the delta region, and we can see the difference of the two areas. And on the mountain, because of the topography, and the A horizon is 15 centimeters. If we look at the delta region, where the soil was washed away, especially the top layer, the rich layer of the soil was washed down from the mountain, the A horizon is 150 meters, almost tenfold of the soil above. And the B horizon is on the top on the mountain, that is 25 centimeters. In the delta region, it's 15 centimeters. So the nature plays a role, and the geological features and the topography also play important roles in the soil. Again, this is a picture how bad the soil is eroded in different areas of the world. The Asia and the Amazon forest area is the worst. Another picture, and check out the textbook. And I want you to read the whole chapter of the textbook. You can focus on the soil texture, soil structure, and the soil profile. And it's very well written to help you understand those very important concepts. I want to mention about these bad incidents happened in history. This is around 1930 in United States, and it's called the Great Plains area, about like 10 states in the middle of United States. And because of improper agricultural practices, the soil is very severely eroded.